All right, guys, we're going to do page number 36 today. This is about the ideal gas law. So this is kind of the last equation we're going to learn before or for the unit, I guess. Okay, so this one's the ideal gas law. Okay, so go ahead and put a box around it. So let's talk about what each of these variables are. These should be familiar to us: pressure, volume, moles, temperature. This one is not super familiar. This is our gas constant. And this is where you're going to find your values for R. Okay, it's going to be one of these three things. It's probably most of the time going to be this one. Now look at these three. What is different about them? The units on these look a little bit crazy. They're pretty long because it's a combination of a whole bunch of units smashed together. But what's the difference between them? The difference is the pressure component. So this one has atmospheres, this one has kPa, this one has millimeters of mercury. Okay, so I feel like we use atmospheres more than any other pressure unit. Now, obviously, we do get things in kilopascals, millimeters of mercury, torr, psi, but I won't give you one with psi with this equation. Okay, but this one is the one we're going to use, like if no, and so make this note in your notes. You should write this down so you don't ask me later. If no pressure is given, use this one. So for example, if the problem wants you to solve for pressure, so you don't know which units to use, just use this top one. Okay, in every other situation, whatever pressure is given in will tell you which one of these three to use. So if pressure is given in atmospheres, you use this one. If the pressure in the problem is given in kPa, you use this one. If the pressure given in the problem is in millimeters of mercury, you use this one. Okay, but if you're asked to solve for pressure and you don't know what units to solve pressure for, just use the top one and do ATM. Okay, so you're going to look at your pressure units to figure out which of these three to use. Okay, a couple other notes I want to put on here. First is temperature. Reminder, must be in Kelvin. Must be in Kelvin. Okay. Volume. Okay, this one's special. This one's special. If you notice, all of your gas constants have volume in liters. So that means that for this equation and this equation only, your volume has to be in liters. It can't be in milliliters. If it's in milliliters, you got to change it to liters, okay? Your other gas laws we learned about, it doesn't really matter if it's in milliliters, as long as it's consistent on both sides of your equation. In this particular one, PV equals nRT, it does matter. Volume does need to be in liters, so it'll cancel with these units here. And then pressure, we know there's a whole bunch of different units for pressure. It could be ATM, kPa, mmHg. Okay? Okay, so maybe let's go into a practice problem here. So this is PV equals nRT. Some people like to call this the Pivnert equation because it spells out Pivnert, not to be confused with pervert. Pivnert. Okay, so make sure you're getting all the variables in the right order if that helps you remember, okay? Okay, so let's do an example. The first example says at what temperature in Celsius will 0.780 moles of neon gas occupy 4.30 liters at 1.75 atmospheres. Okay, so first thing is looking at this equation, or looking at this problem, you know it's different than the other problems we've done because on all these other problems we've done in your packet, you're always given like two pressures and two volumes. There's like a P1 and a P2 and a V1 and a V2 or whatever. This one, there's only one of each. You're only given, one pressure. You're given one volume. Moles is N. You're given one number of moles. And you're trying to figure out the temperature. So that's how you can tell on a test that you're getting a PV equals nRT equation or PV equals nRT problem is that you're only going to have one of each variable. Okay? So let's write our equation. PV equals nRT. Okay, and let's figure out what are each of these going to be? P, V, N, R, T. Okay, well, we just said P is the 1.75 atmospheres, right? V, we said, is 4.30 liters. N is 0.780 moles. R, okay, what's R? Well, R is going to be one of these three things. So look at our pressure units. So maybe let's make it a look at your, write this down, pressure units. Look at your pressure units to figure out which one to use, okay? Pressure is given in atmospheres, so let's use the top one, the one that uses atmospheres. So it's going to be 0.0821 liters times atmospheres over moles times Kelvin. I know those units are long. Okay, and temperature is what I'm looking for, so that's my unknown. Let's plug everything in. Okay, so P, V, liters, and it's already in liters, so that's good because you got to make sure your volume's in liters, equals N, oops, that's a 780 moles. That's your N. R, we said we're going to use the 0.0821 liters times atmospheres over moles times K. And then T is my variable. That's my unknown. So I've got everything plugged in beautifully, except I made a mistake, but that's okay. Okay, now we need to get T by itself. So we're going to divide by these things. Okay, so we're going to divide by the 0.780 moles. And we're going to also divide by the 0.0821. Okay. Do it to the left side so they cancel. Do it to the right side. I know it seems tedious that we're writing all of this out, but let me show you, especially in the examples, why it's good to write out everything with the units and everything, because it helps to keep you from making mistakes. So these we showed canceled, right? Okay, so now I know I need to do this times this divided by this and this. So I'm going to go 1.75 times 4.3. Okay, then I'm going to go divided by, and then you can either divide by this, press enter, and then divide by that, or you can put it in parentheses. Either way, you should get the same answer. So I'm going to divide by 0.78. I'm going to hit enter, and then I'm going to divide by my 0.0821, press enter, and I got this number here. So T equals 117.50835 ... Okay? Okay. Now, what is this in? Okay, well, it's temperature, so it's probably Kelvin, but look, you can check. Atmospheres cancels with the atmospheres here in your R units. Liters cancels with liters here in your R units. Moles cancels with moles. And look, at the only thing that's left over is K. So that's kind of cool. All right, so I'm going to round this to 3 sig figs. So that's 118 Kelvin. All right, and let's see. The question, be careful. You always want to go back and read the question again. Question says, at what temperature in Celsius? Is this Celsius? No, this is Kelvin. So remember, if you want to go back to Celsius, you have to subtract 273. So I'm going to go 118 minus 273. 118 minus 273, and I get negative 185. That is cold. Degrees Celsius. That would be your answer in Celsius. Now you only need to convert back to Celsius if it tells you to, and it does tell you to in that problem. Okay? Okay, so it's not very different than your other equations that we've done. You just plug and chug into the equation. The only thing that's different is you need to figure out which R to plug in. Other than that, it's pretty much the same. So I'm going to give you a minute to go ahead and do the U-try. Keep in mind, in this one, you are asked to find pressure. You're asked to find pressure. If you're asked to find pressure, it doesn't tell you what units pressure is looking for, so use the top one. So if no pressure is given, just use this first one so your pressure comes out in atmospheres so that we can all be consistent. Okay, so I'll give you a moment to go ahead and pause the video. Go ahead and do the U-try. All right. Here is what I got for the U-try. You can go ahead and pause this on my work right here. Hopefully you are able to get the same thing. Okay, you're solving for pressure. All right. And keep in mind your temperature is in Celsius here, so you had to convert it to Kelvin by adding 273. Okay, so there's the U-try. Okay, on the back of this paper, you have 6 problems to do. So go ahead and work on those 6 problems and hit submit.